Hello, ladies and gentlemen. Welcome to section 3.3. Much of the same stuff that's going to be happening in 3.3 is very similar to what we did in 3.2 and 3.1. We're going to be talking about time-distance relationships today. Okay. Vocabulary that you need to know that we have up here. I think some of it has already been covered by Mrs. Steffen in physical science. So if you've had physical science with Mrs. Steffen, you should be good to roll here. So what's going to happen here is they're going to give us a scenario, and they're going to say, okay, we start 1 unit away. After 1 second, we're 4 units away. After 2 seconds, we're 7. After 3 seconds, we're 10. They're going to then ask you to how fast are we moving, and then we got to graph it. So what this means is we've got our time, which we've already discussed is our x-axis, and then our distance, which is our y-axis. And okay, and these are, if when they say we're so far away, whatnot, it means we're talking about like a motion sensor. If there's a motion sensor there, we're going to start at a certain distance away. We're walking forward or backwards from it. Okay, so when we start, that's when x is 0 and our distance is 1. So after 1 second, we come to 4. 2 seconds goes to 7. 3 seconds goes to 10. Okay, so that's how this is going to look like in a table, very similar to what we've done before. Okay, so they want to know how fast we are moving. That's where we're finding the rate. Okay, and the rate is the difference of our distances over a course of 1 second. So in this case, we've traveled 1 second. We've moved 3 seconds. So our distance would be 3 units, because I don't specify anything, per second. All right, so if it give you a feet, it'd be 3 feet per second, or inches, 3 inches per second, and so forth. But since I didn't give us any units, I just said units. We have 3 units per second. Okay, so now what they could also ask us to do was they could say, okay, let's graph this. All right, and when we graph this, we start at 1 second away, so we're there, and then after 1 second, or 1 unit after 1 second, we're 4. After 2 units, we're at 7, and after 3, we're up off the graph at 10, and we've got that linear plot there. And so that's very similar to what we've done, what we did in section 3.2. Like I said, we're meshing everything together in that standpoint there. Okay, so now what could also happen is, we have that information here, and they could say, okay, explain the scenario. Okay, so they say, here's a table, so explain what's actually happening. So in this case, we've got this table here, and so we're looking for our start value. So we're starting at 0, we're 6 units away. So, we could say we started 6 units away from sensor. All right, and after 1 second we were 2, or 4 units. After 2 seconds we were 2. After 3 seconds we were 0 units away from the sensor. So we could say we started 6 units away from the sensor and moved towards the sensor at 2 units per second. Okay, so that would be explaining the scenario. So if you're asked to do that, if your rate is positive or plus, you're moving away. Okay, when your distance is getting greater from the sensor, you're obviously moving away. If your distance is negative, or your rate's negative, you're moving towards it. Okay, so in this case we are moving towards it because our speed or our distance here is getting smaller each time. Okay, and then the final aspect that we'll talk about is we could be given. Okay, we start at so we've got our time and our distance. We got 0, we start at 6, and then they say, okay, we don't know what's in between here, but we know that in 5 seconds we were at 26 units. Okay, we don't know what's going on. They want to know, okay, how fast were we moving? Okay, and they're going to say, assume that everything is in a linear relationship, that everything is constant. You didn't speed up and slow down and all that jazz there, as everything was constant. So you had 5 seconds that were covered, and then 5 seconds happened when you were walking, and you covered this amount of distance. Okay, so this would be our ending distance. This would be our starting distance. So we would take our end minus the start and subtract out and then divide by total time. For those of you that are familiar with acceleration in science, this is exactly what we were doing there. So that's 26 minus 6, and then divide by the total time was 5 seconds. So that's divided by 5. Order of ops as we simplify this, so that's 20 divided by 5. So we're moving at 4 units per second. Okay, and obviously we were moving away from the sensor. If these numbers, if we started at 26 and ended at 6, this answer would be negative. But you can't really have a negative speed. You'd have a negative acceleration, so we'd be moving towards towards the sensor in that case. All right. Here is the try on your own problem for section 3. Given the scenario on the table, explain how this walker moved during the time provided. Please answer this question in your notes, as well as getting your paragraph written down as to what you learned. If you have any other questions, make sure you let me know, and have a good day.